Hey everyone, welcome back. Today we're exploring interaction design in TouchDesigner by building a digital cat's cradle. We're not just drawing lines here, we're building a reusable interaction engine. We're taking the raw hand tracking data from mediapipe and forging a direct link between your physical hands and digital space. We want this to feel tactile, responsive, and grounded. We want to make sure that your setup lands on its feet every time. And we need to lock the aspect ratio so the cat's cradle web doesn't just bounce around the screen when we composite it. We aren't kidding around. Let's build. Part 1. The engine room. Start fresh. Inside Project 1, create a base comp and rename it WebSim. Dive inside WebSim and create an in-shop. This is where the tracking data enters our system. Now jump back up to the top level. Make sure you have the mediapipe component in your network. Click on the mediapipe component. Go to the mediapipe tab and turn on Detect Hands and hit Generate GUI next to Detect Hands. That will create the hand tracking component. Dive into the hand tracking component and find the chop named Normalized Data. Make sure the values are changing by checking the chops upstream or connecting your own select chop and seeing that it's outputting values. If it's not changing, we won't proceed. So fix the tracking first. If you need to go back to Torrent's tutorial on how to use the plugin, that's here. Now, jump out of hand tracking and connect that normalized data output into your WebSim in chop. Part 2, Designing Anchor Points. Back inside the WebSim base comp. For good interaction, we need stable anchor points. If we only track fingertips, the cat's cradle yarn floats away when you close your fist. It creates a total catastrophe. So we'll include the wrist. Create a select chop. We're going to use a wildcard here. This is the cat's pajamas for saving time. In the channel names, type H1:**X. That asterisk in the middle is the wildcard. It tells TouchDesigner, I don't care if it's a wrist, a knuckle, or a fingertip. If it belongs to hand 1 and it has an X value, I want every one of those values. Next, add a shuffle chop and connect it. Set the shuffles method to sequence all channels, and then the rename value of the channel to TX. Now we need the Y and Z axis. Draw a box around both nodes, the select and the shuffle. Copy them, paste them. In this new copy, change the select channel to H1:**Y. Then change the shuffle rename value to TY. Paste the select and shuffle chops one more time for the Z axis. Change the select to H1:**Z and change the shuffle name to TZ. Wire all 3 shuffles into a merge chop. Now you've got a clean stream of anchor points for one hand. Part 3, Mapping Digital to Physical. Now let's lock the two worlds together. If the digital space doesn't match the camera frame shape, the interaction feels slippery, like your hand is controlling a shadow that's half a second late. Add a math chop right after the merge, and go to Multiply Add, set Post Add to -0.5. That recenters the coordinate system, so that the center of the camera frame becomes 0. Now add a second math chop. This is the aspect ratio fix, the difference between attached and floaty. On the common page, set the scope to TY. We're only scaling on the Y channel. So now set multiply to your vertical scale value. If your output is 16 by 9, like mine is, like most people's are, set the multiply to negative 0.5625. Take your output height divided by output width, then make it negative. That number is your TY multiply. So that way you could calculate it if your webcam is slightly different size and not just regular HD. So landscape uses a smaller number and portrait uses a bigger number because portrait is taller than it is wide. Finally, we're going to add a dedicated flip switch for the vertical axis. Add a third math chop right after math 2, and on the common page, set the scope to TY. On the multiply add page, set the multiply to -1. What this node does is it flips the Y. So if your web ever moves up when your hand moves down, you don't have to redo the math. You could just bypass this node and instantly test the other orientation. Think of it as a light switch for Y is upside down. Part 4. Digital Visualization. Let's add color so we could see what is happening. Add a noise chop and set the channels to red, green, and blue, RGB. On the common page, set the channel length to use input length. And we'll get the exact same number of colors as anchor points. So add a merge chop and merge the coordinate channels with the color channels. Rename this node left hand final. Now for the right hand, box select the whole left hand chain, copy it, and paste it. In the 3 new select chops, we need to update the wildcard string. So change the H1 to H2, so it becomes H2:**X and Y and Z. Rename the final merge node right hand final. Part 5. Constructing geometry. Now let's turn the channels into real geometry. Add a chop to SOP and connect the left hand final. Set the channel scope to TX, TY, TZ, then red, green, blue. Set the attribute scope like this: P0, P1, P2, CD0, CD1, and CD2. Repeat the same chop to SOP step for the right hand. You should now see colored points tracking your hands in 3D space. Part 6. The cat's cradle. Now let's unspool the yarn. Add a SOP to pop for the left hand. Add a SOP to pop for the right hand. Wire them both into a merge pop. Add a proximity pop. This calculates the tension between the points. Now, in the proximity pop, set the maximum distance to 0.5. Because we normalized our world to a width of 1, 0.5 allows connections to span halfway across the screen. Set max lines per point to 20. We want a tangled mess, not a hairball. Then add a pop to SOP to convert it back into line geometry. Part 7. The Viewport. Let's render and make it look sharp. Create a geometry comp. Dive inside, delete the torus, it's dead to us, and add an insop. Turn on the display and render flags for the insop. Jump out and wire your web sop into the geometry comp. Create a constant matte. Turn on the point color and apply it to the geometry comp. Create a camera comp and set the translate Z to 5. On the View page, set the projection to Orthographic and set the Ortho Width to exactly 1. That's the final lock. 1 to 1. 1 unit world and 1 unit camera view. So the cat's cradle stays glued to your hands. Create a render top. Set the resolution to 1280 by 720. Create a video device in for your webcam. You can also just create an in top and jump out of the web sim and get that value from your mediapipe comp and connect it to your in top. Use a composite top to layer the render over the video. And there it is, a responsive generative web that feels physically attached to the hand. Now you can use this rig for particle physics or just a ton of digital yarn. Thanks for watching. I'm feeling pretty good about this one. And I'll see you next time.